Okay, and we are live. So, good morning, good afternoon, and good evening to our viewers all over the world. We are back. AppSecEngineer is back again with another live stream in May 2023. So, we're really excited for this one because we're going to be tackling some Google Cloud security. Specifically, in this live stream, we'll be talking about logging and monitoring in GCP. So, as we all know, it's our friendly neighborhood, GCP expert here, Ganga Sumanth, is joining us for this one. As you all know, I mean, if you watched our previous live streams, you know that he's the one who's been creating a lot of our GCP content on AppSec engineers. Not only the courses, but also the labs and all of the hands-on content. So he's the guy you should go to for GCP stuff. So Ganga, can you tell us a little bit about what we'll be talking about and exploring in this live demo?
Hey Anish, yeah, thanks for that introduction. Well, this demo is mostly centered around logging and monitoring, and we usually see this on like on-prem services, but we wanted to talk about GCP because a lot of applications always run on the cloud these days, and every cloud provider has a different approach to how they show you their logging and monitoring aspects. So we will be figuring out how GCP does it and how you can access those tools and how you can make them work for you. And that's going to be our session for today.
Okay, that's great. I think you can take it over from here. So all the best.
Thanks. Let's start presenting.
Yep.
Give me one sec while I jump into that screen.
So is the lab that we're doing today? Is that going to be from the actual one of the new courses or something like that?
Yes, exactly. In fact, this is a part of our networking and monitoring courses. We have a suite of courses available for GCP, and this
Okay.
is one of them. The labs that we'll be looking at are actually from our networking course. There are two labs that we'll be looking at today, if we have enough time, that is. But
Yep.
yes, definitely a part of our suite.
Nice. Looking forward to it. All right. Go ahead.
Yep. Okay, jumping right in. So today's agenda is mostly going to be centered around looking at logging and monitoring. And we will find out why we do it at all, what is logging and monitoring, and how we happen to do it on different uh, on the and on the Google Cloud itself. Actually, just give me 1 second. I seem to have the wrong screen up. Right, that should be much better. Let me just go back to that slide. Okay.
I think you need to share your screen.
Yes.
Okay. I think that's good. Yep.
Okay. Okay, so jumping back. So today we'll be talking about logging and monitoring, and let me just start by talking about logging itself. And what is the point of logging? Like, we hear logging and monitoring as an afterthought in most security related premises, but it is actually a very hugely important part of security as a whole. And I want to talk about why it is such a big deal. Well, first of all, if you talk about detection, like the logging gives you detection, like it'll let you know if some security incident has happened, and you can put down parameters that tell you that your application is somehow under attack or something is going wrong. This will let you know if, in the case of potential security breaches, if you have unauthorized access attempts, or even other malicious activities that you have defined in the context of your application. Further, it also lets you investigate in the case of some sort of security breach. It lets you know the things such as system events, user activities, application behavior, etc. These will let you draw out a better picture of what has gone wrong, and further on in the future you could do something better to make sure that this doesn't happen. So, what does investigation really mean? It means that you can reconstruct the sequence of events that led up to that incident, and you can identify the breach, the source of your data breach, and you can collect evidence for maybe legal proceedings that you want to go ahead in the future. It also lets you set up automated threat responses. Let us say you already have a predefined progress chart which says, in case I'm being DDoSed, then ensure that those particular regions are now being locked out. You can, in this way, set up a series of steps that will ensure that your application is protected as quickly as possible. Instead of reacting to a threat later on after you've become aware of it, you can set up a threat flow and a incidents response beforehand. And the more responses that you have, the better secured your application will be for future threats. In fact, you could take this even further, and you can also get performance in analytics, because to be entirely sure, um, your real world application is going to face a lot more stress than any sort of testing that you could put through it when you're developing the application. These analytics are available only through logs, and real world logs will give you the best sort of response ever. Okay. And let us say you're on the other side of the fence and you do not have some sort of monitoring or intelligent monitoring happening that can tell you if something happens. What's the worst that could happen? Well, for one, you could already have somebody within your network. Your application could already be, it could also already be breached in some fashion. And you might be unaware of the security breach. You might have unauthorized users already within your application, and you could simply not do anything about it. And in case you actually find some sort of evidence of tampering, and you have a security breach, without the right logs, you could not actually approach any body, or any legal proceedings cannot happen if you do not have the evidence to showcase that your application has been breached. Also, if you do not have a proper threat response in place, it means that you're waiting until your security engineer or somebody finds out that this breach has happened, and then they start drawing out a response plan of how to react to this breach. That gives your attacker enough time to exploit the vulnerabilities that he's found, maybe take away the data he's found, or even just wreak havoc on your network. Finally, you could also just run into a bunch of compliance violations. A lot of organizations have to, must and should, based on the local laws of the region, have to maintain comprehensive logs and regularly monitor those logs for suspicious activity. Failing to comply with these regulations could mean you could be fined, or you could have to run into like regulatory consequences of not maintaining those logs. Okay. Now, bringing back into the focus of how this works on the Google Cloud platform in specific. We have four major divisions under which Google Cloud does this logging. One is called Cloud Logging, which is essentially one-stop shop for all of your log details. And this collects, stores, and analyzes logs generated by various GCP resources, be it your VMs, your VPC, your storage, etc. Then you have cloud monitoring, which allows for collection and monitoring of metrics such as CPU usage, network traffic, latency, or even errors, etc. Then we have cloud audit logs, which are more of an administrative perspective on how your cloud is being used. This will record activity and accesses within the cloud environment. It is mostly meant to show you that whenever a new compute image is spun up, or certain accesses within the cloud environment are done. The security command center sort of brings all of this under the same wing, and it is a one-stop dashboard for you to monitor all of your resources from a single point. While the others are more configurable to how you want them to work, the security command center is a little more intelligent, and it often acts as a threat response dashboard. Okay, with that out of the way, let us talk about how you would be accessing your information within the cloud, your logs, and how it is stored. So first of all, uh, let's talk about asset inventory, which is a subsection of cloud logging. And cloud asset inventory is an inventory service that maintains a time series database of all of your asset metadata, assets in this case, could mean your VPCs, there could be your VMs, they could be your storage buckets, etc. And for all of these, there are the metadata is retained of these resources for over a course of 5 weeks. In this case, your resources could be VMs, your buckets. Your policies could be IAM policies, as in access management policies, your organization policies, or even access context manager policies. In this case, you would have noticed something called runtime information, and runtime information is the metadata that is associated with your Google Cloud resource. For example, OS inventory management. Okay, on the screen, I've just showcased three different commands that will let you look at what is required within your assets. For example, the very first command is going to show you the result of that is going to show you the IAM policies present within your project. It's scoped within your projects and your particular project name. The next step goes one step further and it shows you all the resources that are listed, and it looks specifically for the compute type instances under your project ID. So all your compute instances running on that project are going to be listed. Finally, the last one, if you see, is not a search. It doesn't do asset search. It's instead doing something called asset export. And this lets you export the details of your VM and that the VM instance that is running on your current project to a certain bucket. And in this case, our bucket is called bucket name, which we're going to be inserting in the next lab that I will showcase very shortly. Okay, so this is just going to be a short demonstration of how to use asset search on Google Cloud. And the very first step, we're just going to search for our resources, for some policies, and the users that are available that can access stuff within your GCP project. Next, we're going to grab an asset snapshot, that is the metadata that is pertinent to our particular project or our particular resources, and we are going to move them to a GCP bucket of interest. And this will allow us to gather that information again and use it for further, analyses. So let me just switch quickly to the lab that is associated with this. Okay, let me just make this a little more legible to you. Okay, control plus plus plus. Yes, okay. So this is one of the labs of on our monitoring and logging course, and what we're doing here is we're going to be using a Terraform script to set up. First of all, we're going to set up a project, and within that project, we're going to spin up a compute instance, and this is going to be a Debian image. It's just a VM, and we've given it an image that it can use to boot from. It's a global image. And to access that, we're also creating a network interface, a default network in this case, and it is going to be accessible within the NAT, like the NAT, the network at the NAT within it. Further, we're also going to create a storage bucket, and it is going to be a random name that is generated using the random string. And finally, all of this is going to be accessible via public IP. So let's go ahead and deploy this instance. So here you're actually looking at one of our courses, the lab that this is associated with. This is the instructions pertinent to that lab. In this case, I've already created a GCP instance. I already have a sandbox project activated for me, so I'm going to be skipping all of these steps. The required APIs have already been enabled for me, and I will just pull up the Terraform script. Okay, now that I'm within that, let me just the project ID for this particular one can be found here. This is my sandbox, so it's only going to last as long as this stream. Okay, just give me 1 second. Okay. Let us search for the IAM policies that are defined within this project. And that can be done using this command. Let us scope it to this particular project where our project name is this random one. And there you have it. So what we've done so far is effectively list all of the IAM policies that are associated with this project. And under this, according to the IAM policies that we already defined, we have under this organization, we have a service account defined, which was created by my Terraform script. And under that, we have a couple of members. One is the compute one, because I'm creating a compute engine. I should also have something that is access to the compute system underneath. And the roles that it has are given here, roles underscore slash compute, and this is a service agent. Similarly, I have a cloud asset service agent, and this is what is doing my logging for me. This is the random service account that was created for me to access this particular underlying project. And finally, Terraform test is the administrative service account that was created when I ran the first when I first created the sandbox account. So that lists every single IAM policy that is currently on my project. Further, you'd also see the bindings that are associated with this project, whether they have editor permissions, owner permissions, etc. And in general, this is a pretty abstract way of looking at things. The CLI is not the most useful if you're trying to visualize things, but there is also a cloud console that lets you look at these things in much better perspective. I will just show you that. Looks like my browser froze. Just give me 1 second. Okay, we're back. So the credentials for this are going to be present in my. So at AppSecEngineer, our sandboxes are spun up as and when you create your you access your course. When your lab is spun up, that is at that very moment your sandbox is created, and it only lasts as long as your lab is active. This means you're allowed to do your entire learning is going to happen within a very controlled space, and you don't have to worry about excessive. Maybe you leave something running. Maybe a compute instance runs a lot longer than it is supposed to, etc. Those are not something you should worry about. But anyway, so to show you the logging console, where is logging? and there's logging. And there you go. So this shows you every single log related to my project within this one window. As you can see, it is a little more overwhelming than you would want it to be. And however, there are various ways to search within this. And I will show you the CLI version of doing so, but you can also do so using the GUI. Essentially, you could say, I only want to look at entries that have, only this image tagged, or maybe you want to see only compute logs that are related to my compute instance. These can be done. Anyway, going back here, let me just bring up my terminal. Okay, let's look at what we can do next. Okay, so here's another way we can look at all the IAM policies that are defined to have the owner permission. The owner permission, as you can understand, is an extremely powerful role, and it should be given as sparingly as possible. So let us see who has the owner permissions on the project that I have just defined. Okay. Just going to replace my project ID. I've created a okay. Let me just find the project ID again. Oh, right. And so this terminal instance did not have a few permissions that were required. Just give me 1 second. I will ensure that it has everything that it needs. And that should do. That should work. So going back to my previous command. Yes. Okay. That should give me the credentials required. And moving on to the projects, it should tell me all my IAM policies, which we've just seen. Okay, that works. And now we should have access to all the roles that contain the owner permission. There you go. And as you can see, we found the service account that was my sandboxed service account, and this one has access to the owner permission. So if anyone were to get access to this service account, they pretty much have control of everything that the project has access to, which is a bad thing. So make sure you take special care of the service account. But moving further, let us see all of the resources that we have under our project that are buckets that we've created using the Terraform script that I showed you in the very beginning. So here I'm going to search for all resources, and within that I'm going to scope it to this particular project as we've done. The project ID can be found here, and I want to make sure that my asset type is set to all the buckets that I have listed. And there you go. So under store, like, it is using the storage API buckets, and it is showing me that I have a bucket called ASC asset with a random name created. The random name is the Terraform's scripts job. It tells me where it is located, which folder it is in, and the location physically is in the US Central 1 region, what organization it is a part of, and what project it is a part of, and when it was last updated. So this is the metadata that is associated with my storage bucket, and I can use this to dig in much further even. Let me do just that. So first of all, let us see the name of the bucket that we just created, and it is this one, ASC asset NVJ, so on and so forth, which I've just pulled using my previous command. And what I want to do now is I want to export the metadata into this bucket, which I will do so using this particular command. Sec seems to have project ID not set. Yep. And also, it is supposed to push this into the bucket that I just found. Bucket name is right here. And there you go. So if I now navigate to that particular bucket, let us go back to my storage, cloud storage, buckets. This is the bucket. And this should take about 5 minutes, I think. So let's keep this running in the background. In the meantime, let us move ahead. It takes about 5 minutes to finish the process of moving stuff into this. In the interim, let's just head on forward. Okay. So if you recall, when we were talking about what GCP does when it comes to logging, we had four major subdivisions. One was cloud logging. The second was something called audit logs. And if you remember, I spoke about how audit logs are more of an administrative activity, and they are focused on on showing you what has been modified the last time, maybe configuration or maybe metadata related to your resources. And these instances are recorded using your audit logs. For example, there are log records when users create VM instances or change identity and access management permissions. And these are always on by default. So you would have to like actually go and turn them off if you wanted. But in by default, you'll always have admin audit logs available to you. The next type of audit logs are called data access logs, and these are meant for whenever someone has read a configuration or metadata of a resource that, or even for data. And this is enabled if you're using BigQuery. System event audit logs are Google Cloud actions that modify the configuration of resources. System event audit logs are generated by Google systems, and they aren't directly driven by user actions, and they are also on by default. Policy denied audit logs are when someone is trying to access something that they're not supposed to have access to. They are recorded when the Google Cloud Service denies access to a user for something. So the point of audit logging is that, let us say somebody has access to your Google Cloud environment and they're not supposed to. Well, they could do all sorts of nonsense. They could probably maybe an attacker has access to your environment and now has spun up a bunch of high-powered GPU instances, and he is going to be doing some crypto mining on your resources. Audit logging will let you answer the questions of who did what, where, and when. This is a trail that can really lead you to the answers that you require in these cases, in these some circumstances. It could even be somebody within your company that is doing something that you do not want them to be doing. So let us go to the next phase of logging, and this is more of a network level logging. And in general, on an on-premise device, you would probably put up a firewall. On the cloud, it is a very similar philosophy, except you have firewall logging to tell you what goes wrong and in what circumstance. GCP does something called firewall rules, and firewall rules are applicable to very certain a limited set. They have a scope where you can define that certain protocols, like for example ICMP or RDP or SSH. These are the things that are allowed for your instance, and they'll also let you define what IP address ranges are supposed to be allowed, or what sort of they're essentially firewall rules that can be very granular in the focus of what is allowed and what is disallowed. However, there is one issue. For example, let us say you've set up a web application and an attacker is now DDoSing your application. So, to stop this from happening, you will set up a firewall, and this now has stopped your attacker. However, the firewall could also be blocking a legitimate request. Let us say a genuine user actually wants to access your application, but your firewall is prohibiting that from happening. And that is clearly a bad thing for it to happen, which it basically isolates your application from the world. In these circumstances, if you have, so firewall logging is a technique, like is a service that GCP offers that lets you sort of simulate a firewall rule and tells you whether or not a certain protocol can go through. It is more of a sandbox that tells you what sort of accesses are permitted and what is denied. So, just to go over what I've just talked about, firewall rules logging helps you audit and analyze the effects of your firewall rules, and it helps you determine how many connections are affected by a rule that you've set. And as is the case, they should be applied to each rule individually. Firewall rules logging logs traffic from VM instances, including the app engine. So the app engine is something that we speak about in a different course under our under AppSecEngineer. But this helps you, it allows you to log rules on any of your VM instances. So switching back out, let us showcase a lab that shows you what rules are and how we can log them and how it goes from there. I'll be switching back to let me just tell you what this lab is going to do, and then we will look at the lab itself. So let us say we are going to create a VM instance in this. lab, and then we're going to create a firewall rule that allows you to SSH into the GCP VM. And this firewall rule also has logging enabled on top of it. And this firewall, actually, the rule that we're going to state is going to state that only internal users are allowed to be logging on, that only they're allowed to SSH into your VM instance. Once this is enabled, then we're going to SSH into the instance, and we're going to check if the logs that have to be generated are generated as required. Okay, so switching to the lab in question. Okay, so this is the firewall logs and their analysis lab. So GCP enables the creation of firewall rules to allow and direct traffic to instances within your the VP and the VPC that you've created. And by default, all egress traffic is allowed, but all ingress traffic is denied. So in this case, after we set up the VM, we are going to write a new firewall rule that allows you one set of ingress traffic, and that is only SSHing through a particular port that we're going to specify. And this also goes a step further, with we're going to say you should only allow traffic from a certain IP address, and in this case, the IP address is going to be the lab instance that we've spun up. And we can verify that this is what is happening. Like once we do an ingress using that particular lab instance, we are going to verify that the firewall rule has worked as intended. So let's jump right in. Let me just clear this. So I've already done the first few steps. What I'm going to do now is just bring up my resources one more time to make sure that everything is running as intended. In this case, my project ID is right here. Okay, so that is happening. Okay, as you can see, what we've done here is we're going to be referencing. We're going to create a compute engine, and that is being referenced here. We're using a compute manager resource. We're also using the project service, like the cloud resource manager, which allows us to create or destroy certain project wide services. And we're going to be using the IAM policies, which is going to allow us to do create the service account that we require, and then give it the particular owner role that we needed to have. We're also going to create a network. This is going to be a default network, and within that a subnet. And this is going to allow us to permit only a certain IP address to have ingress access to our VM instance. It's going to use a key. We're telling it where to store that key, and the firewall rule that we're applying is right here. If you see, it says it should only allow TCP connections over this particular port, and 0.0.0, this is the source range is pretty much everything, which is, by the way, quite unsafe, but this is for demonstration only. So we're creating an SSH rule that allows it to allows TCP connections over port 22 to happen. Excuse me. And this is mostly just the VM information. The address that it should be using, the IP address, as well as the image that it should be using Debian, and that's about it. Okay, so let's go back and create the Terraform. Uh, let's just bring it up. Okay, sorry. project ID can be found over here. Okay, that should bring up our instance and create the IAM policy that we require, as well as apply the create a VPC and the firewall rule that we require on top of it within that network, so on and so forth. This usually takes about 20 seconds or so. In the interim, let us access the logs on this just to start things up. Okay. So my credentials are going to be here. Oh, there. This is done. Let me just create a new file and just store this so I don't lose it. Maybe it's there. That's enough. All right. Now going back to my console, I just want to log in. Thank you very much. Just logging into my account, sandbox account, just like before. Okay. Let's make sure we chose the correct project. So we'll have access to everything within the project that we require. Now going back, we should see that a compute instance has been spun up. There you go. And further, it should also have a few firewall rules written on top of it. We can find the machine configuration. The HTTPS traffic is currently turned off. There's a network storage network interface that we've just defined. It's called my network. As you could see in the previous one, there was a subnet as well defined. And that's about it. Okay. Now, going back to this, let us check out. Okay, so what we're planning to do is we've created the VM instance and we've ensured that a firewall rule was written to allow ingress traffic on a particular port. And it also so this is an SSH thing that we're doing. So let us first run the SSH command and store the credentials that we require. So let me just one sec. And this is the IP address of that we should be hitting. Yep. And there you go. We've used a service account Terraform test, which was the admin service account, and we've logged into the VM that we just created called VM log, and now we should be able to do things within this machine. As you can see, there's nothing in the root. But yeah. So let us run a query within our logging division that you saw previously. Um, let's just go back there. And as you can imagine, like last time, there should be a huge chunk of information with which is going to be quite hard to parse through. So we're going to write a few queries to ensure that we have the right information. Analytics, logging should be there, logging. And let us go to, okay. Okay, so we have a time series a time series chart of everything that has happened on this particular project since its inception. And it was first spun up at 9:16. I was testing about an hour ago, and the current one was right now at 10:17, which is only a few moments ago. Any which way, let us write a query to ensure that we get the information that we require. And this is the query. I will break it down once I copy it in. So the project ID in our case is going to be okay. So what we've done is we're going to check the subnetwork that we've created. And within this subnet, we're looking for our particular project and we're going to look for every firewall log that was created. Let's just run this query. And there you go. So we see the instance in which this remote connection was allowed, and it shows you several details underneath it. And they should tell you every single time that ping was done with from the lab instance server to the VM that we created within our GCP instance. As you can see, all of these were allowed connections, and this will continue to refresh because as long as that the lab instance is still active, it will continue to ping more and more, generate more and more logs. So if I were to go back to this and let us say I run, uh, there you go. That just this activity should generate a few more logs. Let's just run this query again. And there we go. The most recent log is even newer than before. But this is only the firewall log, but I want to go further deeper, further inwards. I want to know who accessed my VM, and by who I mean what IP address accessed it. If you remember, when we created the firewall rule, we did not specify who was allowed to have access to it. Like we only had a 0.0.0, which means basically a blank check. It says anybody can access it. But let's see who's gotten access to this. Okay. So in this case, I will just retain all of this and only take the last line because everything else is actually the same. And the IP address in this case will be the IP address of this lab instance. So let me just create a new one and run server IP. This returns the IP address of the slab instance, which I will come back and drop here. And that should be it. I can run this query. There you go. Now this is pertinent to the access that was generated, like the one single instance of access, wherein I SSHed from my lab instance into this gcloud VM, and everything else is not relevant to us because the VM that we have access to is also SSHed by the by different resources. But this is the one that was done by this IP address. What I'm trying to tell you is the query language that is built onto this has sufficient depth to allow you to drill down further into the details and extract only what you require. The implication of this is that you can write quite intelligent stuff on top of this to extract the details that you require. For example, every time I see this IP address, if this IP address is requesting SSH access to my VM instance, then I could write some queries on top saying that maybe monitor how long this happens for, and if it exceeds a certain amount of time, I could spin the VM down, or perhaps I could ensure that uh, this IP address does not have access to certain VMs within my network. These things can be done because I have some sort of logging information that is available to me. Now let's just yeah, that should effectively demonstrate the topic. So I will just make sure that this is done, and let's go back here. Okay, so moving right on. So this is the lab that we've just used, and what we've done is we've set up a firewall rule and we've SSHed into the VM that we've created, and these firewall logs have been stored in in the log explorer that I just showed you, and we can write custom queries on top of it to showcase the firewall rules that are in action and how they're being used. And it has sufficient depth to allow you to extract certain it allows you to drill down further into the information that you have using only certain keywords, like let us say you only want the IP address, or maybe just the ports, or maybe even a specific VM that is in action. All of this can be done using the query language that is built into your log explorer. So that wraps up what I wanted to discuss in this particular setting, but there are quite a few more things that we did not touch upon, and I just want to highlight them before we leave. So the very first thing is we have something called VPC Flow Logs, and this is a quite a fascinating topic which allows you to essentially recreate everything that is coming in contact with your private network. And the flow logs are essentially a mirror image that will let you uh, maybe run forensic information, maybe do detection, and even like send all of this information to your security manager. And this will allow you to take actions before something goes wrong. It's more of a proactive approach than most of the things. You might have noticed that I said something about BigQuery. BigQuery is baked into GCP, and it allows you to extract your logs and store them into a bucket and analyze them in real time. And this allows you to build, again, more intelligent sort of detection and a response loop than would be allowed in a regular thing. There are several network monitoring tools on display within the cloud environment, and this is available under the monitoring subdivision. And this is more of a dashboard that lets you look at things such as like the network information, such as how much CPU usage you're currently running, or how much how many connections are currently established with yours, what sort of latency you have within your network, etc. And finally, the security command center is a one-stop dashboard that you can create and customize according to your needs. And it is also intelligent in the sense that it can showcase all of your vulnerability scans that you've already done on your application, and these are shown in real time, and it's more of a visual approach to how you want to look at your application. And yeah, that about wraps up what I want to talk about logging and monitoring within the GCP platform. And what I've just showcased is a small portion of what we have under the logging and monitoring course. We have many more labs available under the same subdivision. And I think that's my cue. I will hand it back to Anish at this point.
All right, that was great. That was a really fascinating live stream, and I'm really hope all of our viewers really learned something from this. And just remember, this is obviously part of one of our courses. Is it an upcoming course, or is it one that's we already have?
It's actually already live, and I've also showcased something that we've just brought to GCP on our platform. That is, we have a new sandboxing feature that lets you do everything only within our course, within the AppSecEngineer website, without having to sign up onto GCP yourself. So
Right.
do check it out.
Yeah, that's a great new feature. That'll be part of the Pro Plus subscription, not the regular Pro subscription. Just FYI. So that brings us to the end of our live stream for May, and I really hope you guys enjoyed this one. And we can't wait to join you next month with another fascinating, live session. In fact, next month we're planning to bring these new sort of live webinars called Friday Fireside Chats with guest speakers, not just people from AppSecEngineer. So I hope you look forward to that, and I'll see you next month. All right. See ya. Bye-bye.
Bye.